We're here today to go over the liver lab. So we're going to talk about how to do the graphs on the liver lab and how to answer the questions on the liver lab. Hopefully everybody who's listening to this has already seen the screencast on the liver lab. So I basically did what you would have done in the lab. Sucks that you didn't get to do it yourselves. And I have two computers going at the same time. Sorry, so you're seeing me probably on two images. I just wanted to be able to monitor the chat in case you had a question. But please, you are welcome to unmute. That might be easier, and just ask a question. So interrupt me at any time that you have a question. So just really quickly to remind you sort of what was happening in the lab. We're using cow liver, beef liver. Why did we use beef liver? Because it's an inexpensive meat that we can pick up at the grocery store. We could have used any source of meat. Even plants have the enzyme that we're looking for. So I could have cut off my pinky finger. Gross. And we could have used my pinky finger in this lab, but liver is sort of an easy meat that we can use that has this enzyme. And the enzyme is called catalase. And basically catalase's job is to break up hydrogen peroxide. Hydrogen peroxide is a toxin. It's poisonous in your body. And that's why we don't drink hydrogen peroxide. It'd be terrible for you. But hydrogen peroxide is also an antiseptic, which means that if you get a boo-boo, you might put hydrogen peroxide on your boo-boo. And some of you may have had this before. Does anybody know what happens when you put hydrogen peroxide on a cut?
Bubbles.
It bubbles, right? It's kind of sweet. It's kind of fun. Okay, a cut always hurts. So anytime anything gets into a cut, like when you're cleaning it, it's always going to hurt. But technically, hydrogen peroxide doesn't hurt any more than water would hurt. And it basically cleans out your wound and it adds oxygen to your wound. There's a lot of different types of bacteria that hate oxygen. And so if you flood your boo-boo with oxygen, those bacteria die. And so it's a great way of keeping your wound clean. So here's the question. Why does your body, why does a cow's body, why does a plant's body have hydrogen peroxide in it? And why do we have this enzyme if hydrogen peroxide is bad for us? Well, just really quickly, your body accidentally produces hydrogen peroxide when you're digesting fats. It's like nuclear waste. When you're making nuclear energy, you also produce nuclear waste and it's bad. Well, hydrogen peroxide is something that your body produces that's bad. So your body also makes this enzyme that's called catalase, and it makes that enzyme to immediately break up the hydrogen peroxide. So as soon as your body accidentally makes hydrogen peroxide, you have an enzyme that attacks it and turns it into water and oxygen. Oh my gosh, your body is brilliant. It takes something that's poisonous and turns it into something that's awesome for you. So we all have that enzyme in our bodies, and it's in the cow body and whatever. So now what we're going to do in this lab, what we did in the lab, is we adjusted different variables. So we used sand and hydrogen peroxide. And that was a control group just to show you that nothing happens when you put sand and hydrogen peroxide together. So that's just showing you what happens in the absence of an enzyme, of a catalyst. We'll practice those words a little bit. The next experiment we did, experiment number 2, was with a catalyst that's called manganese dioxide. It looks like a black powder, and it is a catalyst, but it's not one that you have in your body. And it causes the hydrogen peroxide to bubble, and it makes the oxygen and all that. But it's not something that you have in your body. So those were our 2 control groups. Then we had a whole bunch of variables that we kept changing to see what impact it would have on the reaction. The first one was we just took a piece of liver at room temperature, we did nothing to it, and we dropped it into the hydrogen peroxide, and we saw that the enzyme catalase that was in the liver and is also in your bodies broke up the hydrogen peroxide really fast. It produced oxygen. We did a flame test, all that stuff. Then we adjusted some variables. So I don't remember what order it was in. You'll have to look at your data table, but we boiled the liver. So what does heat due to our enzymes. What happens, for example, if we have a really, really high fever? So boiling it was supposed to mimic what happens if you have a fever over 108 degrees. We froze the liver. We made the liver really, really cold, although I wasn't able to do that well in the lab video. It was supposed to be frozen solid and yours wasn't, and I'll get to that. But freezing the liver is supposed to show what would happen if you experienced hypothermia. So on a really cold winter day, your body temperature starts going down. What does that do to the chemical reactions in your body, the enzymes in your reaction? We also crushed it. Crushing it, this was a question that some students asked me earlier. Crushing it is how we change the enzyme concentration. So when we first had the first cube of liver, the hydrogen peroxide just touches the enzymes that are on the outside of the cube of liver. But then in one of the experiments, I crush it in a mortar and pestle. So that cube of liver is now splayed all over. And all of the enzymes that were hidden on the inside are now spewed out everywhere. So now when I add hydrogen peroxide, it should react a whole lot faster because it's coming into contact with the enzymes that were on the inside. So that was a way that I increased the enzyme concentration. In the whole liver, we had enzymes on the outside. In the crushed liver, we had the enzymes on the outside and all of the enzymes that were on the inside. And then to wrap up the experiment, we changed the pH. So we put the liver in an acid, we put the liver in a base, and we put the liver in neutral water, and then added the hydrogen peroxide to see what impact changing the pH would have. I'll give you one example really quickly. Your blood is supposed to be at a pH of about 7. That's neutral, and that's like water. However, if you hold your breath, you're producing carbon dioxide inside of your body, and you hold your breath, that carbon dioxide mixes with the water in your blood, and it makes something called carbonic acid. So then you start developing, when you're holding your breath, you start developing acid inside your body. Your body's pH starts getting lower and lower. And the question is, what happens if you stay that way? If you're not breathing at all, or if you're not breathing well? Well, it lowers the pH. And what does that do to the enzymes in your body? And that's what we were experimenting with in the lab. Okay, so now let's go ahead and take a look at the graphs. The first graph, so I'm going to present here really quickly so you guys can all see. The first graph that you were supposed to do, I can't remember now. I have to pull it up. Give me just a second. Cross that off. Okay, the first graph that you are asked to do, give me just a second here, is the reaction rate versus the liver temperature. So we had the liver at 3 different temperatures. We had it, the very first experiment we did was at room temperature. Then we did a boiled one, which represents if you have a really, really high fever. And then we did a frozen one, which represents if you have hypothermia. So how is the reaction rate affected by the different temperatures? So I gave you on Classroom, I gave you this sample graph. I strongly, strongly recommend that you go to Classroom right now. Those of you that are listening, go to Classroom right now, pull up this graph, and then do a file, make a copy so that you have your own version of it, because then all you have to do is edit it. So if you open this same exact thing that I'm working on right now, if you open it and then do file, make a copy for yourself, you can edit it however you want to, and it doesn't affect my graph and it doesn't affect anybody else's graph. So just, I'm trying to slow time so that you have time to get to Classroom and open this graph, and then you can work on it with me at the same time. And then if you have any problems, you can ask me while I'm sitting here with you. Okay, so the first thing that we're supposed to do is mark it with temperature versus reaction rate. So the variables where it says variable 1, variable 2, and variable 3, we're going to change those because notice that they are the labels for the graph. Let me just say one thing too. Labeling a graph is incredibly important. And I know students get frustrated when teachers take points off for mislabeled graphs or graphs that aren't labeled. But I want you to imagine for just a second, I thought of this scenario and so I'm trying to make a quick point here. If this was a graph, let's say you saw this bar graph and there were no labels or anything, you just saw this bar graph, you'd be like, okay, what's that a bar graph of? What if somebody gave it a title, a really lame title that just said pandemic? That was the title of the graph. You'd be like, what about the pandemic? What is that? Let's say there were numbers on the side, and maybe even on the side it said people or it said deaths or something like that. You'd be like, okay, this is a graph about people that have died in the pandemic, but is this people in Minnesota? Is this people around the world? Is this, what are the different bars? What do they represent? So then you need to be a little bit more specific in your title. So maybe the title should say something like deaths in Haiti by COVID-19. Okay, now the title actually means something. Okay, we know what we're talking about. We know where we are in the world, and we know, that it's about deaths. And then it would be even more specific if you said 2019, because this is 2020. So if they're dying in 2019, that's kind of important. Add to that, if the bars were labeled March, April, May, all of a sudden that becomes a super important graph, because you're finding out that people, this is not true, by the way, I just made this all up. You're finding out that people were dying in Haiti in March, April, and May of last year. And we thought coronavirus started in Wuhan, China last fall. So there's people dying in Haiti. Okay, so I'm trying to make a point that the labels are incredibly important. Over on the side where it says deaths, if you forget to put the unit thousands, somebody might think, oh, well, 9 people died from coronavirus, but it's really 9,000 people that died. So, okay, maybe I beat that to death, but just trying to make you understand that I will look at these graphs, I will look for a title, I will look for a label, and I will look for units. It is important that you have those things written down. Okay, so the first one that we're going to do, variable 1, we could say is room temperature. So go ahead and edit that little box. If you've copied and made a copy for yourself, edit it to say room temperature. And then the second one, the second box, we could edit and say boiled. I should have made a copy for myself. You know what? I think I'm going to do that, you guys, so I don't ruin my original. Give me just a second. Give me just a moment, because I don't want to ruin the one that I have for everybody.
Is the bar graph supposed to be up?
Yes, it is. Is yours not?
Yeah, it is. I was just wondering.
Yeah, I definitely want it, because it'll, as you edit these little things, it'll edit them on your bar graph. I think it will. Give my computer just a second to get caught up with this. Yeah, do you see that down here it edited? So now my bar says room temp, it says boiled, and then the last one should say frozen. So those are our 3 different temperatures. So now the reaction rate, we need to write down the correct reaction rate. And I think for yours, you guys could correct me. Did we say the room temperature? So it would have been experiment number 3, the whole liver at room temperature. Was that a 9 or a 10? Do you remember what we said?
It was a 10.
Thank you. So we're going to put in a 10. The boiled should have been a 0. Was it a 0? Anybody?
Yep.
It was a 0. So we're going to put in a 0 for the boiled. And then the frozen, what's interesting about the frozen isn't how high it gets. It's how long it takes to get there. So it should have come out to a 9 or a 10 also. There's nothing wrong with the enzyme when it freezes. There's nothing wrong with the enzyme. It's still working, but it works more slowly than when the enzyme is at room temperature or body temperature. So you should have a 10, 0, 10 graph, and we can just finish at that. And now our title isn't quite right. So there's a couple ways to edit the title. The best way is to click on these 3 little dots in the right-hand corner of the graph. And then I click Edit Chart. I'm going to try to not go super fast. Click Edit Chart. I think I clicked Edit Chart. Did it work? There we go. And I'm going to go to Customize, and we're going to change the title of this graph. So I'm going to click Customize. Trying to not go too fast because I know you're trying to keep up with me, and I know it's frustrating when somebody goes too fast. Interrupt me, say, whoa, slow down, KJ. Because if you're having trouble keeping up, probably 16 other people are having trouble keeping up.
Wait,
Okay.
where's the edit chart thing?
Say that again.
Where's the chart editor?
It's these 3 dots in the right-hand corner. Can you see where the bar graph is, where I'm circling right now? Click those 3 dots.
Okay, yeah, I see it.
Got it? I always think that's tricky. It's not super obvious that that's there. And then you want to click Customize, the tab that says Customize over here. And now we're going to click, and some of you may have gone ahead and done it, which is awesome. Click your chart title, and instead it says Replace with name of variable. So we're going to say temperature. Oh, and it doesn't need to be in parentheses. Oh my gosh. It's jumping all around. Temperature versus reaction rate. So that's our title of our graph, temperature versus reaction rate. The reaction rate technically, let's see if it'll let me, whoops, I'm going to scroll up here. I'm going to change where it says chart title here. I'm going to say vertical axis title. I want to change that just a little bit. So I'm going to click on vertical axis. It says reaction rate right now, which is great, but I would like to be more specific. We went from a scale of 0 to 10. So now we've got our units. Those aren't real units, but that makes people understand it's a scale of 0 to 10. And then down at the bottom, so notice that it updated already on the graph. The graph updated as I typed it in. So now I need to fix my horizontal title, which currently the label on my horizon, that didn't make sense, says replace with name of variable. So we're going to replace with name of variable. We're going to call it temperature. And ladies and gentlemen, in a science classroom, what is it? Oh my gosh, what is it always in a science classroom? Anybody know?
Celsius.
In Celsius, that is correct. And I was trying to figure out how to make a degree sign on a Chromebook. Does anybody know that?
No.
I know how to do it on a, so we'll just write C for this one, unfortunately. I know how to do it on my laptop, on my Mac, but I don't know how to do it on the Chromebook. Okay, let's just look over the graph and make sure we feel good about it. I feel like that's a good graph. So now you can do a couple of things. So I'm going to go back out here and I'm going to click on the graph and I'm going to do an edit copy, and I should be able to paste the graph. I'm going to do paste, and I should, and it doesn't matter if you link it to the spreadsheet. If you link it to the spreadsheet, then you can edit it again if you need to. So I would just hit paste, and now my graph got pasted in there in the correct place. I'm going to shrink it down because it's a little too big. It's kind of hanging off the edge. So I'm going to grab the corner and make it a little bit smaller. And now I have my temperature versus reaction rate graph done. Okay, I'm going to delete this one just because this is my original and I don't really want it in here. Next thing that you can do, here's my next suggestion. You have a temperature versus reaction rate. If you kept them linked, then you should do another file, make a new copy. So file, make a copy, and do another copy of this graph so that you can edit and it won't affect your first graph. If you linked them and now you try to edit them, you'll affect your first graph. So I just copied it, and now I'm doing a new graph. And this time, let's look. I'm going to go back to the Liver Lab report and see what we're supposed to do. This one is supposed to be reaction rate versus environmental pH. So this is where I'm going to compare the acid, the base, and the neutral to each other. So let me go back here.
TJ,
yes.
It won't let me paste my graph into the document.
Did you, okay, so just really quickly, did you click? So do you see that I have the little boxes all around it? Do you see these little squares all around my graph? Did you on the graph? Okay. And then did you do a control C or a copy?
Yeah.
Wait, yeah, how do you, I can't figure out how to copy it.
Do I link spreadsheet or do I paste it unlinked? I'm
going to say link it in case you decide there's something you want to change. In case it's not, go ahead and link. And then Mandela, was that a question?
Yeah, how do you copy it?
So you should, do you see how I have the little boxes on my screen right now around the graph?
Yeah.
I got those by clicking on it. And then you do Control C at the same time. So Control is your bottom left hand button, Control C, and then go back over to your liver lab report. And then you click where you want it. So make sure your cursor is right where you want it. And then you do Control V. That's for paste.
Where should I put it?
Right under the, see where it says graph number 1, reaction rate versus liver temperature? That's where it goes.
Oh, okay.
I'll show you where mine went. So link, paste. And there it is. It's a little bit tricky to see, but it's underneath the title.
Yeah,
right.
I got it. Thank
Got
you.
it? Okay, good. I'm going to make that go away. Now we're going to do the next one. I started editing the second one. So again, for Mandela and Nija, why don't you make a copy of that previous, so you already did this one. It's on a tab. And now I want you to go File, Make a Copy so that you have another tab. And this is going to be a whole new graph, and it'll be fairly easy. So we're comparing the acid. I'm going to change this title from boiled to base. And then I'm going to change this one to neutral. And some of you, I'm sure, are working faster than I am. I would love it if somebody would remind me the numbers that we gave for the acid, the base, and the neutral. What did we give for the acid? Anybody out there remember or know it?
I think it was 1.
1 is a very sensible one. I think the base was higher than I thought it would be. Was the base like a 6 or something, Jair?
I think it was a 9. Yeah, it's 9.
It should not be that high. I don't know what happened there. So we'll give it a 9. That kind of sucks because it really should not be that high. And it's kind of misleading information. And then I think neutral would have been 10. Is that right?
Yeah.
Okay, so I've got my graph pretty well set right now, but the title and the label, the horizontal label, are incorrect. So I'm again going to click on the graph. I'm going to click on the 3 dots, and I'm going to do Edit Chart. And then when I edit that, when it takes its time, there we go. I'm going to click Customize. And then Chart and Axis Titles. And I'm going to change my title to, whoops, pH, which just tells me acid, base, or neutral. So pH versus reaction rate. Done. And now I'm going to change my horizontal axis to pH. And with pH, that sort of is your unit. There's no unit to go with that one. So we can just say pH, and we're done with that. How are you feeling about these, you guys? Are they the graphs working and making sense?
Yeah.
Thank you for one person answering. Okay.
Yes.
Okay, thank you. I'm going to go ahead and make my third graph. Scream at me if I'm going too fast. So I'm just going to do a copy. I'm sorry. Oh, sorry. The first thing you need to do is make sure you paste this into your lab report. So the first thing I'll do is Control C, sorry. And I'm going to paste it in for the second graph. So that's graph number 2, and I'm going to paste it in. Sure, I'll link it to the spreadsheet. That's fine, because if I want to edit it later, I can. Uh-oh. Uh-oh. Mine says temperature versus reaction rate, so I copied in the wrong one. Hold on, what did I screw up? This is mine. Control C. Make sure that you paste your correct one in. I don't know what I did wrong on that one.
AJ, mine did the same thing.
Why? What's happening? What are we doing wrong, boo-boos? Tell me what's going on.
Try pasting unlinked.
Pasting unlinked. Why? I was hoping that by just making a copy of the liver lab graph that you wouldn't have to worry about linking. Okay, we'll do it without linking, you guys. I thought this would take care of it, and apparently it didn't. So we're going to hit paste again. And this time we're going to paste unlinked and see what happens. Nope, still not.
Oh.
That's so annoying. What's going on? I'm so sorry, you guys. Okay, well, the last one that always works is a screenshot.
I think it's because also.
Go ahead.
I think it's because you copied it from the last chart.
I'm sure that's why. I'm sure that's why. But I thought if I copied it, it wouldn't copy linked. I thought it would be a new one. And that's why I was having you copy it. So I'm really sorry about that. Do you all know how to do a screenshot? That'll take care of it right off the bat. Do you guys all feel like you know how to do a screenshot? I got to remember, is it, I think it's Control Shift and then that button above number 6. Does that sound right?
Mm-hmm.
Yeah. And then your screen goes dark.
It worked for me because I copied a whole nother graph off of the sample graph you gave. So like I have 2 different copies of graphs now.
And it did work for you. That's super interesting. Okay. Okay. Well, great. Mandela, thank you for that tip. So people who are listening, who are watching the screencast can do what you did. So anyway, I was just so that is how you do a screenshot. It's Control Shift and then the button that's above number 6, and you drag your icon across like this. So do you see how it's unhighlighted or something? I don't know. The whole screen is gray, and then and all I do is lift up my finger, and it took a screenshot. And so I'm going to copy to clipboard. And then now I'm going to add this into my lab. I'm sorry, guys. I thought we could be able to do that. So insert image, upload from computer. I'll do it again if I'm going too fast. Upload from computer. And then recent is always one of my categories. So the most recent one is the one that I'm going to pick. So do you see that there was recent right here? And then the one that's at the top is my most recent picture. And again, make sure that the label is right, because that's how you know you did it right. And this one, excuse me, is pH versus reaction rate. So we know we have the right graph in there. Okay. How are we doing? I'm gonna go ahead and do the last one in case people are working faster than me and they're getting tired of me going slow. So I think I'll X out of these 2 tabs, and I'm gonna do what Mandela did, and I'm gonna do a file, make a copy of this one. I don't know if that'll work, but I'm trying. We'll try something new. Okay, and this last one is the enzyme concentration graph. So I'm going to look back at my liver lab just so you know what I'm talking about. So, the last graph, sorry, there we go, is reaction rate versus enzyme concentration. In other words, comparing the whole liver to the crushed liver. So this time there's only two that we're looking at. Usually we've been looking at 3, this time just 2. Does somebody have a question? No? Okay. So this one I'm going to change from room temperature. The one mine says room temperature. I'm going to change that to whole liver. And I'm going to change boiled to crushed liver. And then I'm just going to delete variable 3 and its number. So you got to make sure there's no number over there. And the whole liver, I think, was a 10, and the crushed liver was a 10, if I'm not mistaken, which is a little bit not great either, but that's okay. We'll take it. So 10 and 10. Now my bars look correct on my graph. Now I just need to click, and those 3 dots, I'm going to click on them, and I'm going to edit my chart again. I'm going to replace the name and make it enzyme concentration. I got to click customize to customize my graph. Chart and axis titles, and then chart title. This one is going to be called enzyme concentration versus reaction rate. And I see I didn't fix this on the last one. That's too bad. The reaction rate should be on a scale of 0 to 10. So I am going to fix that just while some of you get caught up with me. So the vertical axis title, I'm going to change to on a scale, scale of 0 to 10. Oh my gosh, I'm having so many troubles. There we go. And then I'm going to change my horizontal axis title to enzyme concentration. And for this one, there is also no unit. There's no, we're not counting the enzymes, so I can't say in millions or per liter or anything like that. I don't have a unit that goes with enzyme concentration. All right, and then that graph is done. So I'm going to try, I'm just going to see if I can do a copy and paste on this one because I'm guessing I cannot. So I'm going to click on it, control copy, and I'm going to try to paste it, but my guess is it's going to paste to the temperature one, but we'll see. It pasted that one. How did that happen? What am I doing wrong? It doesn't matter. We can always do a screenshot. I'm not at all concerned about it. I'm just kind of playing with it right now to see. Control copy and control paste. Didn't paste anything this time for me. No clue. I'm not going to worry about it. So I'm going to take a screenshot of mine. And then I'll just paste my screenshot. So Control Shift and the button above number 6. And I'm going to move my, what do we call that? Not the icon, what is the bullseye called, you guys? What am I dragging over to the side? Whatever. Okay.
Cursor.
Thank you. Why was that word skipping my mind there for a second? Good. Okay. I'm taking a screenshot of my enzyme concentration, copy to clipboard, and now I'm going to insert it into my insert image, upload from computer. And then I want to pick my recents, and I'm going to make sure that I'm uploading the right one. It's so easy. You've already seen me make that mistake. It's so easy to upload the wrong one. So make sure that this one says enzyme concentration versus reaction rate, and it does. So we are done with our graphs. I'm going to move on. You can always come back and finish up your graphs if you're not quite done. I just want to make sure that we get through the questions, and then I can set people free who feel like they know what they're doing. And then if you need to stay and have questions or something, we certainly can. All right. I kind of explained this in the intro to today about what catalysts do. Catalysts basically speed up reactions, but they don't get used up. So the liver has in it an enzyme that's called catalase. And catalase's job, and the equation is right here, catalase's job is to break hydrogen peroxide, which is written H2O2, that's hydrogen peroxide. It breaks hydrogen peroxide, and you see the arrow, into water, 2 molecules of water, that's why it's got a 2 in front of it, and oxygen. And that's what's bubbling every time we do the lab, is those are bubbles of oxygen. And so it breaks it down. And then this image shows you, and this is in today's notes. I do a presentation on enzymes today that you're supposed to take notes on. This gray thing is the enzyme. So that would be catalase. That's its name. This green would be the hydrogen peroxide. So the hydrogen peroxide and the catalase touch. They fit like puzzle pieces. And then the catalase breaks the hydrogen peroxide into a molecule of water. It's actually 2 molecules of water and 1 molecule of oxygen. And that's what you see. It broke it up. That's the chemical reaction. And it happens way faster if you have an enzyme. If you don't have an enzyme, it still will happen, but super, super slow. So that's the shelf life of hydrogen peroxide. If you leave hydrogen peroxide in your medicine cabinet for 10 years, it might go bad. And that's because eventually hydrogen peroxide breaks into water and oxygen all by itself. But it would happen in a matter of seconds if you dropped a piece of liver in your bottle of hydrogen peroxide. It would bubble all over and make a big mess, and you could show your family and laugh. And okay, then your mom would get mad at you because you just wasted your hydrogen peroxide. All right, let's go ahead and get some answers. Be ready to type fast, and I'll just go through this with you so you feel good about it. What's the function of a catalyst? I kind of just said it. Does anybody want to pipe in? What do catalysts do? And again, most of the answers are either right here in these 2 paragraphs or from the lab itself. So what? Go ahead.
Break the hydrogen into water and oxygen?
Yes, and that's too specific though, Mandela, and I'm going to get to that in just a second. So if you were going to say it more generally, what do catalysts do? What's the function of a catalyst? It speeds up and controls a chemical reaction. So you could just write, it speeds up reactions. Done. You got your first question answered, okay? And Mandela, you're right. We're going to get to that in just a second. Okay, number 2, why can manganese dioxide, that was the black powder, why can it be called a catalyst but not an enzyme? And let's see, it says here, an enzyme is a catalyst found only in cells. So do you think that black powder, I used it for test tube number 2, do you think that black powder is found in your body? I hope not. So that's why it's not called an enzyme, because it's not found in your body. You could say it's not made by cells. So why can manganese dioxide be called a catalyst? It speeds reactions, but not an enzyme. It's not made by cells. So you could say it speeds reactions, but it is not made by cells. Good answer. Okay. Number 3, write the chemical equation for the decomposition of hydrogen peroxide. Well, ladies and gentlemen, we just highlighted it a moment ago. This is it right there. That's the equation for the decomposition of hydrogen peroxide. If you're dying to make the little 2s, oh, I know how to do it on a Mac. It just suddenly occurred to me I don't know how to do it on a Chromebook. Let me see if I can figure out how to make it.
It's control period.
Control period?
Oh wait, control comma, I think.
Control comma. Okay, that's okay.
Yeah.
That is the same. Then that is the same on a Mac. So it would be, so I typed in my H and then I do control comma and then the number 2. And then I do control comma to make it big again. So then it would be, oh, oops, what did I click on there? Sorry. O, and then control comma to put that 2. So if you like making those little numbers, but if you made it all big, I don't care. I'm not grading on the size of your numbers and letters. So, all right, number 4. Why was the glowing splint used? Anybody? What does the glowing splint, what was it showing us? What was it testing for? Anybody remember?
To test if there is oxygen.
Good. What would happen, and I can't remember if I said this in the lab, what would happen if I had done the glowing splint test with some pop? So let's say I poured 7-Up into the test tube and shook it and it bubbled, and then I did the glowing splint test. What would have happened in that circumstance? Who knows the answer to that? Anybody? The bubbles in pop are made of carbon dioxide, not of oxygen. So they would suffocate the flame. So instead of it starting on fire again, which is what oxygen does, the fire would have been extinguished by the carbon dioxide. So it would have gone out. And let me just add a little quick aside. Our planet is perfectly, unbelievably, miraculously balanced with the right amount of oxygen. If we had a tiny bit more oxygen than the first lightning strike, our planet would burn off all of its atmosphere in a split second. It would all get used up. We have just a little low enough amount of oxygen that the whole atmosphere doesn't burst into flame. So, hey, pretty cool. Okay, number 5. What was the purpose of taking the temperature of the hydrogen peroxide before and after? I'm going to scroll up to the top because, oh, it doesn't say it at the top. That's because we have a different lab version since you guys weren't in the lab. So the purpose of taking the temperature before and after is that temperature changes during a chemical reaction. So it's evidence of a chemical reaction. So a temperature change, let me say that again. Temperature change is evidence of a chemical reaction. And the bigger the temperature change, often the bigger the reaction is. And the smaller the temperature change, the smaller the reaction. All right, what were the control groups in this experiment? We already talked about that. So we had 2, you could even argue 3 control groups for this experiment. The first one was the sand. Remember, a control group is not an experiment. So it's just sort of what's the normal. So what does it look like if there's no catalyst? So sand is what it looks like if there's no catalyst. The hydrogen peroxide doesn't bubble. The next thing we did was the manganese dioxide, which is MnO, and then you could use your little control comma to make a 2. That's the next control group. That's what the reaction looks like if you had a catalyst in it. So what does it look like when it bubbles? The last one that you could argue was a control group is the whole liver. So that's if you have catalase that hasn't been treated with an acid or a base or changed the temperature or crushed or whatever, that would be another example of a control group. All right, and then why did you use control groups? And this is the same answer for every experiment ever. What is the purpose of a control group? Why do we have control groups? What are they for? I have to pick up my doggie right now because she was being cute, and so I just need to hold her for a moment.
Oh my God, what's her name?
Her name is Trixie. Thanks for saying it like she's cute, because I think she's cute.
She is cute.
Thank you. We had to give her a pandemic haircut, and we did really good. I bought some clippers, and she was so good. And she doesn't look terrible like you see mostly on the internet these days. So she was good. Okay, control groups are for what? What's the purpose of a control group? So that you can, what's the word we always say?
I don't know. I'm trying to think.
Control groups are for comparing. So you can compare, the experimental results. Experimental results. So if we didn't have a control group, if we didn't know how the whole liver was supposed to react, how would we know that boiled liver was any different? If we didn't have that control group. So control groups are for comparison so that you can compare your experimental treatments. All right, what are the 3 independent variables in this experiment? In other words, what 3 variables did you intentionally adjust to see their impact on the enzyme? That's what our 3 graphs were. So what were the 3 topics of our 3 graphs? What were the 3 titles? What 3 things did we adjust in our graph?
pH.
pH, good. What else?
Enzyme concentration.
Enzyme concentration and temp. Nice. Those are our independent variables. So then it says, what are the dependent variables? In other words, what did you measure once you changed the independent variables? What were we measuring? We actually measured 2 things, 3 things. We measured 3 things. Anybody else? It's been so quiet. I've heard from Mandela and I've heard from Jair. Is Clyde still there? Nija, anybody want to try? What were we measuring? I'm giving you a hint. Reaction rate. So we measured how fast the reaction rate was going. We measured with a splint test. So that's more of a qualitative result. It's like a yes or no answer. Did it relight? So the splint test. And then the temperature change was the other thing that we measured. All right, number 10, I already answered with you guys earlier. Explain how you increased the enzyme concentration. So what did I do that made it as though there were more enzymes than there were the first time? Anybody, how did I increase the enzyme concentration? London? Anyone? Anyone? Bueller? Okay, I increased the enzyme. You guys are just
the crushing of the liver.
Thank you, London. Good. That's right. We crushed up the liver. So that gave us access to enzymes that were trapped on the inside of the liver that we didn't have the first time. So in comparison to whole liver, the crushed liver had more enzymes. That reaction, they were both a 10 because they both went over the top of the test tube. But technically, the crushed liver should be faster than the whole liver. The whole liver gets there. It just takes a while. The crushed liver should go super, super fast. All right, number 11, is hydrogen peroxide useful in cells? Wait a minute, what did we say about hydrogen peroxide? Hydrogen peroxide is a
poison.
Thank you. All of you. Good. Poison. It's bad for us. Now, on the surface of your skin, it's fine. You can use it to clean a wound, but you don't want it inside of you. And that's why you have an enzyme that gets rid of it right away. Number 12, why is catalase necessary in cells? I kind of just answered that. What does catalase do? What is its function?
Helps break up toxins.
Helps break up hydrogen peroxide in particular. So not just toxins in general, but the toxin hydrogen peroxide. Perfect. And then the very last question, I know some of you are typing as fast as you can. Why does hydrogen peroxide bubble when placed on an open cut? So Mandela knew it bubbled. What's going on? Hint, you have catalase in your blood. So when you get a boo-boo and you pour hydrogen peroxide on it, why is it bubbling? What's going on?
Isn't it because like it's bringing all the oxygen up?
No, not exactly. It's because you have catalase in your blood and you're bleeding. And when you touch hydrogen peroxide to it, the catalase is breaking down the hydrogen peroxide into water and oxygen. And so that water and the bubbles are oxygen, Mandela. You're right about that part. But it's not bringing the oxygen from somewhere. It's basically just breaking up the hydrogen peroxide into water and oxygen. And then you see the oxygen bubbles that are coming out. And that's good for you. That's healthy for your tissues, and it keeps bacteria away. All right, weirdos, we got all done. That took a little bit longer. It always takes longer than I think it's going to. Sorry about that. How'd you do? Is there anything should I stop the recording? Is there anything you still have questions on? Do you feel like you understand? Are you ready to submit?
I'm missing question 4.
Question number 4. Why was the glowing splint test used? What does it test for, Mandela?
Which one was the glowing splint again?
That's where it was it was a wood stick that I had that I lit on fire, and then I blew it out. So it was glowing, but it wasn't on fire anymore. And then I put it in the test tube, and it starts back on fire if there are bubbles there. So what are the bubbles made of if it starts back on fire?
Oxygen?
Oxygen, good. So the glowing splint test was done to test for oxygen. Okay. All right, I'm going to go ahead. I know some of you are still working. I'm going to go ahead and stop the recording now. You may head out if you're done. If you don't need anything, say bye, because I love it when people say bye. But I am done. And then if you have questions, let me know.
Bye, KJ.
Bye, Mandela.